Hello, girls. I hope you're staying safe at home. So, here I am again to start a new chapter in chemistry. So, as you can see, we are going to start metallurgy today. Okay, now metallurgy actually means extraction of metals. Now, you know, metals cannot exist free in nature because they are very, very reactive with water or with air, that is the oxygen. So they will be found, especially the reactive metals, they will be found as oxides or carbonates or nitrates. So for our daily use, like we use iron, we use aluminum, we use copper, we have to extract it. So that is known as metallurgy. So as you know, there are 118 different elements that we know today, and they are distributed in the Earth's crust, in the free state as well as in the combined form, maximum in the combined form. That is why we need to extract them from their ores. Okay, now the approximate relative abundance of the metals on the Earth's crust, you can see oxygen highest 46.6%, aluminium 8, calcium 3.6. So you can see it in this table how much of elements are present on the surface of the earth. Okay, now you know, when we talk about the elements are divided into two: metals and non-metals. Okay, and how do we know that they are metals and non-metals? Because they have certain properties. So there are 118 different elements, and remember children, only 17 are non-metals. Some are metalloids. Metalloids means having the properties of both metals as well as non-metals. Of course, you have done the metals and non-metals chapter in the lower classes as well. So this is just a short recap for you. Okay. Now, when we talk about metals, I think you learnt in the lower classes that metals are the elements which can be beaten into thin sheets without breaking or made into wires. They have very high densities, and you have to heat it to a very high temperature before it melts, and even a higher boiling point. They have high tensile strength, means you cannot pull it apart. Okay, they are very, very strong, and of course they are very good conductors of heat and electricity. So I just explained what is there in this box. Okay, now when we talk about metals, this knowledge is very, very old. Now you know, you must have learned in history. Okay, copper was the first metal to be used by man for making utensils, weapons, and many other purposes. Okay, then of course there were other metals which were known to mankind from long, long time back. Okay, like gold, silver, copper, lead, iron, tin, antimony, and mercury. Mercury, because of its color, was known as quicksilver. Okay, now you know we use metals in our daily life for a number of purposes, and it is also used in making jewelry. Okay, and coins. Some are used for making utensils, furniture. Okay, and of course, like there are many different heavy metals, heavy machinery is also made up of heavy metals like iron, aluminium. Okay, and different types of tools are made. Okay, vehicles, transport vehicles, and many other manufacturing equipments are also made up of metals. You also have been learning about catalysts, and many metals, you know, are used as catalyst. Okay, not only in the laboratory, but it is also used in various industrial processes like hydrogenation of vegetable oils, manufacture of ammonia, sulfuric acid. When we talk about manufacture, we're talking about in the large scale. Okay, so nitric acid, dyes, drugs, and many other such things. Okay, now, and metals in very small quantities, very small amount, are also important for different biological processes. For example, in our blood, Iron is present, you know that, isn't it? Iron is a constituent of blood pigment, hemoglobin, and zinc is found in insulin, that is a hormone. Cobalt is present in vitamin B12. That means many different types of metals or minerals are required for a healthy body, okay? And magnesium is present in chlorophyll, that is the green colored pigment of plants, okay? So when you are to define a metal, you can define it as the elements which form positive ions by loss of electrons. You know, metals always form positive ions, and hydrogen is the only non-metal which forms positive ion, because hydrogen has only one electron in its outermost orbit and it can easily lose that electron, becoming positively charged. So hydrogen is the only non-metal which forms positive ions. Now moving on to non-metals. Now non-metals are very less in number, but they have a very important role in our daily lives. I told you out of 118 different elements, only 17 are non-metals, okay? So non-metals, exception of course hydrogen, only non-metal to form a positive ion. So when we are to define non-metals, we define non-metals are the elements which form negative ions. How do they form negative ions? By gaining electrons, okay? Now hydrogen is the lightest element known. So in your one word answer, if you get the lightest element known, you will write down hydrogen, or the lightest element, okay? And hydrogen is used in the hydrogenation of vegetable oils, okay? So oil is extracted from vegetables to make ghee, okay? Important vegetable oil is, you know, the refined oils that we use at home, okay? And hydrogen is also used as a fuel and in the manufacture of different compounds, okay? And of course it is an essential part of organic compounds. Organic compounds, remember hydrocarbons, we learned organic when we did organic chemistry, hydrogen was an important part of these organic compounds. Now proteins, fats, carbohydrates, enzymes, vitamins are all compounds of carbon, and they are very, very important for the growth and development of all living organisms, okay? And then we have oxygen gas in the air. For what do we use oxygen? For respiration and also for combustion or burning. You know that burning does not take place in the absence of oxygen. Nitrogen, another element, another non-metal which is present in the air, okay? It is the most abundant element present in the atmosphere. Children, please remember this. Another one important thing, another important question for one word answer. The most abundant element present in the atmosphere, what will your answer be? Nitrogen, okay? Now it is present in the air and it plays a very important role. Why? Because you know, when fires burn, it uses up oxygen, okay? And because nitrogen is present in the atmosphere, the rate of combustion or burning becomes less. Otherwise, you know, a small spark could cause huge fires. So due to its inertness means it does not, like, you know, have any it does not easily combine with other substances. It is inert, so it is used to preserve food, okay? You must have seen inside chips packet, it is, you know, bloated up. So when you open, some gas escapes. So what is put inside? Nitrogen gas, so that your chips remains fresh for a long time, okay? And of course life would not have been possible if there were no non-metals like carbon, oxygen, nitrogen and hydrogen. So these are important non-metals, okay? Now all the metallic elements, all metals are solid, exception is mercury. So if you are to name a liquid metal, what will your answer be? Mercury, okay? Now out of the 17 non-metals that we know, okay, so 11 are gases, one is a liquid, the only liquid non-metal is bromine, and the remaining non-metals are solids, Okay, now astatine, okay, if you see in the periodic table, you'll see it right at the bottom of the halogens, okay, is right at the bottom. No one knows what it looks like. It is very rare. Okay, that rare means you find it in very small quantities. It is the rarest naturally occurring element. So again, one word answer, rarest naturally occurring element. What will your answer be? Your answer will be astatine. So it is a halogen. Now certain elements are present which shows the properties of both metals and non-metals. They are also known as semi-metals, or you know it better as metalloids. Okay, they are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. So please remember, metalloids have the properties of both metals and non-metals. Now we have done the periodic table, so you know that metals are always on the left side and in the middle, but non-metals are on the extreme right side. Okay, elements in group 13, exception is bromine, are metals. Boron. Boron is metalloid. Okay, and the metallic nature increases as you move down the group. And elements of group 14, 15, 16, 17, most of them are non-metals, though of course a few at the bottom of the group show some metallic nature. Only one non-metal, that is hydrogen, has been placed on the left side of the periodic table, and you know the reason why, because it can form positive ion by losing one electron that is present in its one and only orbit. Now, and of course the metals and non-metals in the periodic table are separated by a zigzag line of metalloids. So metalloids are in the center. Now, the activity series of metals we've already done in the part 1 of this book when we did the hydrogen chapter, if you remember. Okay, so activity series of metals are the arrangement of metals in decreasing order of their reactivity. Okay, so this is known as the activity or reactivity series. The metal which is the most reactive is placed right at the top, and the one which is the least reactive is placed right at the bottom. Okay, so you have already learned the activity series of metals. So there you have the activity series. Kind nations can manage all zones, freeing public hunger, accumulating huge amounts of gold. So there you go, we've already done that. Now, the metal potassium is kept at the top of the series because it is the most reactive. So if you are to name the most reactive metal or element, your answer will be potassium. Okay, and it is also the most electropositive also. Why? Because it can easily oxidize. It can easily combine with oxygen and give up its valence electrons which is present in its outermost orbit. The least active metal right at the bottom is gold. Okay, so that is right at the bottom. Now hydrogen, you can see, though it is a non-metal, it has been included in this series. Why? Because it can form a positive ion. I have been telling you again and again, hydrogen has only one electron in its outermost orbit, which it can easily lose. Once it loses, it becomes positively charged. Okay, so you can see hydrogen is between lead and copper. Okay, so the main points of the activity series, we have already discussed that as well. So you know, any metal which is higher up in the series displaces any metal from below, from the salt solution of the latter. Supposing you have copper sulfate plus zinc, there will be no reaction. Why? Because zinc is higher in the activity series. But if it is zinc sulfate plus copper, zinc copper sulfate plus zinc, then zinc can displace copper because it lies below it in the activity series. Now, larger the difference in the position of the metals in the series, more rapidly does the displacement occur. So, like supposing potassium sulfate and say iron. Okay, so the gap is very big. So the reaction will take place more readily, more faster. Okay, now oxides of metals, potassium, sodium, calcium, magnesium, and aluminum cannot be reduced by common reducing agents like hydrogen, carbon monoxide, or carbon. Okay, so that is, we're talking about potassium oxide, sodium oxide, calcium oxide, magnesium oxide, aluminum oxide cannot be reduced by hydrogen, carbon monoxide, or carbon. That is why, remember, in the last chapter, electrolysis, these metals were extracted by electrolysis. Okay, we'll be doing that also in this chapter. And oxides of nitrates of mercury, silver, gold decomposes, that is, it breaks down to gives metal when it is strongly heated, that is mercuric oxide, mercuric nitrate, or silver oxide, silver nitrate, okay, or auric oxide, auric nitrate. When you heat it strongly, it can easily be separated. All you have to do is heat it, because you can see they are lying below, right below in the activity series. And metals below copper do not rust easily. Rusting means oxygen is being added, so they do not readily react with oxygen, so they do not rust easily. So where do metals occur? They are found mostly on the Earth's crust, which is the biggest source of metals. So metals you'll find either in their free or native state, as it is called, or in a combined state. So this occurrence of metals is explained on the basis of activity series. Now metals which are less reactive, which lie lower in the activity series, they do not react under normal conditions with oxygen, water, carbon dioxide, or other elements or common reagents. So they are found free in state, that is, they are in the native state, like gold and platinum, which are less reactive, so they are found in the native state or the free state. Now most of the metals are reactive, so they are always found in a combined state, either in the form of oxides or carbonates or halides, sulfides, sulfates, and they are mixed with mud, clay, sand, and stone, because they are found on the surface of the Earth, on the Earth's crust. For example, we have sodium and potassium, which occur as chlorides, calcium and magnesium, which occur as carbonates, aluminium, which occur as oxides, while zinc, lead, copper, mercury, and silver occur as sulfides. Now, the reactivity series lists metals in decreasing order of electropositivity. So the ones at the top will combine with the more electronegative elements. The ones at the top are more electropositive, so they will combine with more electronegative elements in their minerals. So minerals and ores. Minerals are naturally occurring compounds that is found on the surface of the earth. They are compounds of metals, and they are mixed with other substances like soil, mud, sand, silica, silicon dioxide, limestone, rocks. They are known as earthly impurities and are called gangue or matrix. Okay, and what are ores? Ores are those minerals. These, okay, ores are minerals, but from ores metals are extracted commercially, means on a large scale in industries. Lots and lots of metals are extracted, and it must be less expensive at a comparatively lower cost and with minimum effort. That means it should not be difficult to extract the metals. So all minerals are not ores, because from all minerals, metals cannot be extracted. Metals can be extracted only from ores. But remember, children, all ores are minerals. Now there are certain insoluble ores which are found as rocks, but of course there are soluble ones also which dissolve in the rainwater, like alkali chlorides. They are washed away by the rains and they are found in seawater. Okay, so we'll stop here today, children. Now for your assignment, please do this table that you see here, the main ores of the metals according to their activity series, and write down the common ores of aluminum, iron, and zinc. This and this table, and as always, submit it day after tomorrow. Till then, children, stay safe. God bless you.